Hi, this is Algebra 2, Lesson 72. We're starting on page 301. And we're going to talk about lines from experimental data and negative angles. We're going to talk more about experimental data. The book is going to give us the data points for the experimental data graphs. And we're going to have to write in our own lines. So, let's start with this graph right here. It's example 72-1, and they give us all these data points. It says, draw the line that seems to fit the data shown, and then write the equation that expresses salt as a function of carbon. This means salt is dependent on carbon, so salt is our y, and it's dependent on our x, which is carbon. There's never an exact answer to these problems. The experimental data points are often scattered, and we can only estimate a position of the line. Okay, they chose a line that went from almost the center of this, hit this data point, and then came over to these two data points. And then they chose a line that went to the other side and went this way towards these data points. Probably if they had done more experiments, there would have been more data points in a tighter cluster or to one side or the other. So the percentage of error would have been smaller, but this is what we're working with. So, they chose these lines because this line goes through this group of data points. This line goes at least toward this line of data points, and that way all of the data points are expressed in these lines. Okay, so they labeled the lines A and B, and they say that line A appears to pass through the points 140, which is here, and 10, which is right there. That's where this line is going to cross the graph. And also 60 and 1. So that's right there. And line B seems to go through at 40 and 0 and 120 and 6. Okay, so those are the points we're going to use to start to try to find the formula of the line. Because we have an x and y, we can start by finding the slope. So the slope of A, our y's were 10 and 1, and our x's were 140 and 60, so we're going to subtract those and get 9 over 80. So that's going to be the slope of line A. And then the slope of B, the y's were 6 and 0. So that's going to be 6. And the x's were 120 and 40, which is also 80. In this case, we're going to put these guys into decimals. So this is 0.1125, and this one is 0.075. That will make life a little easier for us. And now we're going to work on the equation of the lines. So we have line A. Salt is our y. Remember, it was the dependent. So salt is going to equal the slope, which is 0.1125, times our x, which in this case is carbon, plus B, our y-intercept. Okay, we're going to use 0.60 and 1. To find B. So 1 is salt, which equals 0.1125, and we're going to use 60 for carbon, plus the y-intercept. So 1 equals 6.75 plus the y-intercept. Now we're going to subtract 6.75 from both sides, and we're going to end up with B equals -575. Okay, so this is the y-intercept. So now we can plug that back into the formula, and the formula for line A is salt equals 0.1125 carbon minus 5.75. Okay, that's the formula for line A. Let's do the same thing for line B. Okay, we have salt equals, here's the slope, 0.075 carbon plus B, and the nice line they gave us was 40 and 0. So we're going to use that line to solve for B. Okay, salt is going to equal 0, and the carbon is 40. So 0 equals 0.075 times 40 is actually 3. That's handy. Plus B. So B equals -3. Okay, so to put that back into the formula, we have salt equals 0.075 carbon minus 3. So that's equation B. This is equation A. Okay, now we're going to talk about negative angles. Rectangular coordinates designate the location of a point by giving the distance of the point to the left or right of the origin and the distance of the point below or above the origin. So this is 4 units to the right of the origin and 3 units above the origin. On page 302, they have graphed this nicely, so we don't have to. And we see that this point is 4 away, 4 to the right of the origin, and 3 above the origin. We can locate the same point by saying it's 5 units away from the origin at an angle of 36.87 degrees. When we are doing rectangular coordinates, we always measure the angle counterclockwise from the positive x-axis. This is the only way to designate a point in rectangular coordinates. But when we're doing polar coordinates, we can use either negative or positive angles. So let's look at the next page. So if this is positive 36.87 degrees, if we start at the positive x-axis and we go this way, clockwise around, this angle is 360 minus 36.87, and so that's 323.13 degrees. Because it's going clockwise, we say this is a negative angle, so it's negative 323.13 degrees. So let's try an example. We're going to write 4 at negative 210 degrees in rectangular form. So let's start by doing a rough drawing, because that's the only kind of drawing I can do. Okay, here are our axes. And our angle is going to be at negative 210 degrees. So we're going to start over here on the positive x-axis, and we're going to go clockwise 210 degrees, which will take us just a little past the 180 degree mark. Okay? So this angle is negative 210 degrees. Here's our right triangle. We know that the distance here is 4. So we can call this side A and this side B. If this is 210 degrees, then we went 30 degrees past the 180 mark. So we know that this angle is 30 degrees. And now we can find A and B. A is the opposite over the hypotenuse. So we're going to use sine. So the sine of 30 degrees is going to equal A over 4, or A equals 4 times the sine of 30 degrees. And if you punch that into the calculator, it equals 2. Okay? So B, we're going to find B by finding the cosine, because B is the adjacent angle to the 30 degrees. So we can say B equals 4 times the cosine of 30 degrees, which equals 3.46. Okay, this is in quadrant 2, so our R is going to be negative and our U is going to be positive. And our R is negative 3.46 R plus 2U. So 4 at negative 210 degrees equals negative 3.46 R plus 2U. And that's it for that lesson. Try your practice problems and let me know if you have any questions. Thanks!